Welcome to the third video in the series of videos on factorization, and in this video we're going to stick to the introduction and we're going to quickly look into a recap of identities, what we looked before, and see how we can use it to simplify our expression into factors. So the first one is a squared minus b squared. Now a squared minus b squared can be visualized as this, which is a square, and this is your a plus b term, and this is your these. Let's try with these factors and multiply and see what we get. So a into a would be a squared, a into minus b would be minus ab, b into a would be ab, and b into minus b would be minus b squared. So you see that this and this will get cancelled, and what you will get is a squared minus b squared. So the right factors for a squared minus b squared would be a plus b into a minus b. The second one is a cube plus or minus b cube. When we say plus or minus, it means this is a cube plus b cube is given as a plus or minus. That implies that if there is a plus here, there is a plus on the right side. So that would be a plus b into a squared plus b squared, and if there is a plus, and there would be minus, it would be minus ab. Minus ab. And a cube minus b cube would be, again, the minus in the bottom corresponds to minus in the bottom here, which is a minus b into a squared plus b squared plus ab. A squared plus b squared plus ab. So what you're seeing is two equations compressed into one. So we have decoded this, how to interpret this plus or minus as two different equations that you see here, sum and difference. So there are two ways to see if they are indeed equal. The first way is the method of visualization. So let's quickly try that method. Quite simple. So let's draw. Oh, why don't you pause this video here and try to draw yourself the factors and see what is the area for each of the blocks. So pause the video here and try the factors and multiply and see if you indeed get a cube minus plus b cube for the first one. So if you got this as your as a product, a plus b into a squared plus b squared minus ab, and if you would have got this as your products for each of those terms. By the way, you can also write this as a plus b into a squared plus b squared minus ab would be equal to a times a squared plus b squared minus ab. So that's a times this whole thing plus b times this whole thing, which is this rectangle in the bottom. So a squared plus b squared minus ab. Basically what you did is you take this and then you multiply this, and then you took the b and you multiplied that with this, and that will be a cube plus ab squared. This corresponds to this, and minus ab squared minus ab squared, oh sorry, minus a squared b, and that would correspond to this, plus, so this whole term is done. Now we're going to do this. So b into a squared, b a squared, so that is this, and b cube, and finally minus ab squared, that's this, minus ab squared. And some of these things will get cancelled. Minus ab squared will get cancelled, a squared b is also going to get cancelled, and what you get is a cube plus b cube. So indeed that is true. So you can cancel that, and you can cancel, sorry, a squared b and a squared, and ab squared and ab squared, and what remains is a cube plus b cube. So keep in mind that one important thing to keep in mind would be when you get a cube plus b cube, you will have a plus b, a plus here and minus here, and that's why you have plus or minus and minus or plus here, right? So I urge you to pause this video here and do what we did for a cube minus b cube, for proving that a cube minus b cube is indeed equal to a minus b into a squared plus b squared plus ab. I would request you to do this both visually, which is what you have done here, and also through the traditional algebraic multiplication method. So try to do it in both ways and convince yourself that that's indeed equal to a cube minus b cube. Please pause the video here. So in the visual method, if you would have got this as your table, you're absolutely right. And if you add up these elements, a squared b and minus a squared b minus plus ab squared and minus ab squared, what you get is a cube minus b cube. Now to do this algebraically, you do this and you multiply a into a squared plus b squared plus ab, and you take this minus b as such, minus b into a squared plus b squared plus ab. That would be a cube plus ab squared, this and this are same terms, a squared b, this and this are same terms, then minus b into a squared minus b squared, this and this would be the same term, minus b into b squared would be minus b cube, again same, minus b into plus ab would be minus ab squared, which is the same term. So here you would find that they cancel exactly as before, and you'll be left with a cube minus b cube. The next one is something which we would remember from the previous videos, which is a squared plus b squared plus or minus 2ab is a plus or minus b the whole square. What that means is if you have a squared plus b squared plus 2ab, you would get a plus b the whole square, which is a plus b into a plus b. And if you get a squared plus b squared minus 2ab, you would have a minus b the whole square, which is a minus b into a minus b. So this is your expression, and these are your factors. You can go ahead and check this both visually and algebraically and confirm yourself. By the way, this is something which we have done in the previous videos on expansion. So yeah, with this we end this video of recap of identities. I hope you enjoy this, and it would be wise to remember these identities, because these would be very useful for solving most of your problems. So until next video, see you then. Ciao, bye.